For this problem, we want to find the lengths of these wires. And I'll start by trying to find this one here. Now what I notice is there's actually a triangle, so I'm going to draw it separately off to the side. So if I draw that triangle, it's something kind of like this. Now, this isn't a right angle. It's a little bit steeper than that because there's a slope on this hill. So I'm just going to connect it like this. In terms of what we know from the picture, I know the length of this side is 50, so I'll label that as 50. The height is 700, so that's 700 feet. I'll put that here. And the thing we don't know is this side, which represents the length of the wire, which I'll call C. Since this isn't a right triangle, you can't use the Pythagorean theorem to solve for it. But if you can figure out this angle, then you can use the law of cosines to solve for the length of C. So the question is, what is this angle? Well, the hill is sloping at 5 degrees, so this is not a perfect right angle. In fact, it's going to be 5 degrees more than a right angle. So this is a 95-degree angle. I took 90 degrees and I added 5 degrees to it. It's definitely a little bit steeper than a right angle. Here's what the law of cosine says. In this triangle, it says that c squared is equal to the length of this side squared plus the length of this side squared. So I'm just going to fill those in. I'll put 50 squared plus 700 squared. But you have to subtract off 2 times 50 times 700, but also times cosine of this angle, which is cosine of 95 degrees. I'm going to get my calculator out and do the rest of this problem. Essentially, I'm just going to take the square root of both sides of this equation, and I'm just really going to type this whole thing into my calculator. And it says to round it to a decimal place, so let's see what we get when we do that. That's the square root of 50 squared plus 700 squared minus 2 times 50 times 700 times cosine of 95 degrees. Okay, I get 706.1, and that is feet. Now to figure out the length of this wire here, same idea. I'm going to draw a triangle for it. So it's something like, okay, well here's the height. The wire comes down like this, and it's not a right angle because the hill is sloping upward, so it's some other angle here. The thing we're solving for is the length of this side, which I'll call C again. I know that this is also 50 feet, and this is 700 feet. This is really looking similar to what we're going to do up here. The only difference is going to be the angle. Okay, this angle, it's not a right angle because the hill is moving upward, but what angle is it? Well, it's going to be 5 less than 90 degrees, so this time it's an 85-degree angle. So all I did to figure out this angle was I took 90 degrees and I subtracted off the 5 degrees that the hill is sloping upward. From here, if you want to solve for the length of C, by the law of cosines, c squared is equal to 50 squared plus 700 squared minus 2 times 50 times 700 times cosine, but this time it's cosine of 85 degrees. So I'm going to take the square root of both sides of this equation, and I'm basically just doing this completely within a calculator. C is equal to the square root of all of this stuff. So let's see what we get this time. Entering all this in. Okay, I got that C is equal to 697.4 feet if I round out to 1 decimal point. So that is everything for this problem.